All right, getting ready for a power electronics engineer interview. That's great. We've got some RoleCatcher intel right here to help you really nail it.
It's pretty awesome how RoleCatcher goes beyond just giving you some sample questions.
Yeah.
It's got all these career guides and AI tools to give you feedback and help you shape your answers for different jobs.
It's like having a secret weapon.
Exactly.
So before we even get to those questions, though,
Sure.
we need to understand what power electronics engineer really does, right?
For sure. They're like the brains behind the circuits that make our electrical systems work so well.
Mm.
Everything from the little DC converters in your phone to the massive motor drives in huge industrial plants.
But it's not just circuits, though, right?
No, it's not.
You also have to work on mechanical design problems
Yeah,
and with other engineering teams.
absolutely.
So it's a mix of things.
It is. It's a really dynamic role that needs you to be good at the technical stuff, know how to solve problems, and be a clear communicator.
Okay, speaking of communication,
Yeah.
let's look at a classic interview question.
Okay.
Can you explain the difference between a rectifier and an inverter?
All right. Well, with this one, they're checking your basic knowledge.
Right.
You'll want to explain how both of these parts work within a power electronics system, but keep it easy to understand.
So how would you explain that?
You could say something like a rectifier is kind of like a one-way street for electricity.
Okay.
It converts the AC power from the wall outlet into DC power,
Right.
which is what your devices need.
Mm-hmm. And what about an inverter?
You can think of an inverter as the opposite.
Okay.
It takes DC power, like from a battery, and turns it back into AC power.
Which is what we need for our appliances.
Exactly.
Yeah.
You've explained things clearly, even using analogies to make it memorable.
So you aced the question,
Yeah.
but then the interviewer might ask,
Uh-oh.
can you give me a real-world example of where you'd use a rectifier and an inverter?
Okay, so that's a follow-up question.
It is.
This is your time to really show what you know.
Yeah. You could talk about how a rectifier is used in a laptop charger
Right.
to give the battery power.
Mm.
And then an inverter is used in solar power systems to convert the DC power from the panels to usable AC power for your house.
So those are really good examples.
Yeah. Real-world examples always help.
They do. They make it more interesting.
Absolutely.
Yeah.
And with RoleCatcher, you can look at tons of career guides for specific industries, like if you're interested in renewable energy or the automotive industry.
Oh, that's cool.
Yeah, to find even more examples to help you tailor your answers.
That's really helpful.
Yeah.
Okay, let's go to another question that you might get. Can you describe your experience designing power electronics circuits?
All right, this is your moment to shine.
Yeah, okay.
Don't just list your projects.
Yeah.
Really walk the interviewer through your design process.
Okay.
From the initial idea to testing and actually making it work.
Got it.
Talk about specific design tools and simulations that you've used.
So like specific software and things like that.
Exactly.
Exactly. Bonus points if you highlight a challenging project and how you overcame obstacles along the way.
Yeah, challenges are always good to talk about.
Yeah, they really are.
So RoleCatcher's career guide has a good tip for this question.
Oh, what's that?
Highlight a project where you had to think outside the box or troubleshoot a tricky issue.
Oh, yeah. Interviewers love that.
They do.
They really want to hear how you solved problems.
Exactly. So you could say something like, in one project, I had to design a DC-DC converter with really strict efficiency requirements.
Yeah.
I used simulations to get the best circuit parameters and component selection,
Yeah.
which helped me build a converter that performed even better than expected.
That's a great way to show off your technical skills and your attention to detail.
It is.
All right, let's change gears a bit
Okay.
and talk about reliability and safety. A common question might be, how do you make sure those power electronic circuits are reliable and meet safety standards?
Ooh, that's a good one.
Yeah, and this is where you show your commitment to quality.
Okay.
Talk about design principles for making things reliable, like using high-quality components and doing thorough testing under all sorts of conditions.
Right, because things have to work in the real world.
They do, in all kinds of environments.
We have to test for that.
Exactly.
You can also mention specific industry standards that you know about.
Yeah.
Like, for example, the IEC 61800 for motor drives.
That's a good one.
This shows that you're up to date on all those safety regulations.
Absolutely. Staying current is key.
It is.
You could say something like, to make sure things are reliable.
Mm-hmm.
I always design with a safety margin and do lots of testing.
Okay.
I also stay informed about the latest safety standards and make sure my designs follow them.
That makes sense.
Yeah, safety first.
It is.
All right, now let's talk about high-frequency power electronics.
Okay.
This is getting more and more important these days.
It is. with electric vehicles and renewable energy
Right, exactly.
taking off.
So interviewers might ask, can you describe your experience with high-frequency power electronics?
Yeah.
If you've got experience, great. Detail your projects, the design challenges. But even if you don't have direct experience, you can still talk about your transferable skills
Okay.
and your eagerness to learn.
That's good to hear.
Yeah, show them you're keen.
Yeah.
And RoleCatcher's AI can actually analyze job descriptions
Oh, wow.
to find keywords related to high-frequency applications.
That's useful?
It is. It can really help you tailor your response.
That's amazing.
Yeah, technology can be a big help.
It can.
All right, let's move on to another common question.
Okay.
How do you keep up with the latest developments in power electronics?
Oh, that's a good one.
It is. This is all about showing your passion for the field.
So you could mention conferences?
Yes. That you go to?
Conferences, journals you read, online communities you're part of, even industry influencers you follow.
Wow, there's a lot out there. There is. And the more specific you can be, the better.
Okay.
And here's where RoleCatcher's AI comes in again.
Oh, tell me more.
It can suggest publications and conferences
Oh, wow.
based on the job you're applying for.
So it's giving you even more to talk about?
Exactly. It's like having a research assistant.
That's fantastic.
It really is.
Okay, I think we've covered a lot in this first part.
We have, but there's more to come.
There is. We've just scratched the surface.
Exactly.
We'll dive into even more questions and expert tips in the next part of our deep dive.
Stay tuned.
Yeah, we'll be right back.
All right, so for part 2, let's start with a question that comes up a lot in power electronics interviews.
Okay, what's up?
Can you explain pulse width modulation
Okay,
and its role in power electronics?
so PWM,
PWM, exactly.
big one.
Yeah, it's a fundamental concept.
It is.
So you really want to understand it well.
So how does it work?
Well, think of it as a way to control the power going to a load
Okay.
by switching the power on and off super fast. And by changing the width of these pulses, hence the name pulse width modulation,
Makes sense.
we can control the average voltage or current supplied to the load.
So it's kind of like a dimmer switch?
Yeah, exactly. A dimmer switch for power electronics.
Okay.
You could explain to the interviewer like this. PWM is all about switching the power on and off really quickly.
Okay.
And by varying the time the power is on versus off, we can control the average power delivered.
Okay, I get it.
Now, be ready for some follow-up questions.
Like what?
They might ask, what are the different types of PWM techniques?
Okay.
You could mention some common ones like sinusoidal PWM or SPWM, space vector PWM, SVPWM, and selective harmonic elimination, PWM, SCSHE, PWM.
Wow, there are a lot of acronyms.
There are a few, but to really impress them, you could go a bit deeper and explain the pros and cons of each technique.
Like, for example?
Well, SPWM is simple,
Okay.
but it can create harmonics,
I see.
while SPTWM works better. But it's more complex.
So there are trade-offs.
Always. And RoleCatcher's AI can help you figure out which PWM techniques matter most for the specific job you're after.
Oh, that's really helpful.
It is.
Okay, let's switch gears a bit.
Right.
What about a question on power semiconductor devices?
Okay, like what?
Like, what are the key differences between MOSFETs, IGBTs, and thyristors?
Okay.
And when would you use one over the other?
Right. This question is really testing your knowledge of those building blocks of power electronic circuits.
So those are the key components.
Exactly. You want to show that you understand how they work, their strengths, and their weaknesses.
Right. So how would you answer that?
Keep it clear and concise.
Okay.
You could say MOSFETs are fast-switching devices.
Okay.
They're great for low to medium power applications, like switching power supplies. IGBTs can handle higher currents and voltages.
Okay.
So they're good for high-power applications, like motor drives.
And thyristors?
Thyristors are best for really high-power stuff, where switching speed isn't super important.
So each one has its place?
Absolutely. It depends on the application.
That makes sense.
Okay, now let's tackle a question that often trips people up.
Oh, I hate those.
I know, right?
Ew.
Tell me about a time you had to troubleshoot a really complex power electronics problem.
Okay.
What did you do and how did you fix it?
Ah, so it's a story.
Yeah, it's a behavioral question.
Right.
This is where you really show off how you analyze problems and solve them.
Okay, so how do we tackle this one?
Remember the STAR method?
STAR.
Situation, task, action, result.
Oh, right.
So pick a specific example that shows how you methodically troubleshoot.
Okay.
Start by describing the problem,
Okay.
what equipment was involved, and what could have happened if you didn't fix it.
Right, so the impact.
Exactly.
Why?
Then you explain the steps you took to figure out what was wrong.
Okay.
Talk about the tools you used.
So like multimeters and things.
Exactly. Multimeters, oscilloscopes, logic analyzers,
Right.
and the specific things you measured or observed that helped you narrow down the cause.
Okay, and then the solution.
Right. Describe what you did to fix it and how it all turned out.
So like a happy ending.
Exactly. A success story.
Give me an example.
Okay, you could say, in one project, a high-power inverter kept shutting down randomly.
Uh-oh.
I used an oscilloscope and saw these voltage spikes on the DC bus.
Okay.
I kept investigating and found a bad capacitor in the snubber circuit.
Ah, so that was the culprit.
It was, and replacing it fixed the problem and stopped those shutdowns.
So a good save.
It was, and sharing a clear example like that really shows that you can think critically and solve tough problems.
That's great advice.
Okay, now let's shift to a question about safety again.
Okay.
What are some important safety things to consider when designing and testing high-power electronic systems?
Okay, so back to safety.
Yeah, safety is always important.
It is, especially with high power.
Exactly. This question shows that you're committed to safety
Right.
and that you take engineering seriously.
So it's a good chance to make a good impression.
It is. Emphasize following those established safety standards
Okay.
and best practices.
So what would you say?
You could start by saying, safety is the most important thing in high-power electronics design.
Okay.
You have to include safety features like protection against overcurrents and overvoltages and isolation barriers.
Right, those are important.
They are, and don't forget about personal safety.
Oh, right, like wearing gloves.
Yeah, you could add, when you're testing these systems, always make sure it's de-energized before you connect anything.
Yeah.
Wear the right gear, like safety glasses and insulated gloves, and work in a safe environment with safety interlocks in place.
So those interlocks are like a backup.
Exactly. They prevent accidents.
That's good.
Yeah, by showing that you know about safety and that you always follow the rules,
Mm-hmm.
you build trust with the interviewer that you prioritize safety in your work.
Okay, I like that.
All right, let's change gears again.
Okay.
Let's talk about a question that focuses on the future of power electronics.
Okay, the future, I like it.
Me too, it's exciting.
So what kind of question are we talking about?
Something like, what emerging trends in power electronics are you most excited about?
Okay. And why?
So this question is all about showing you're passionate and that you know what's happening in the field.
Exactly. Think about those technologies we talked about.
Like wide bandgap semiconductors.
Yeah, wide bandgap semiconductors, renewable energy, electric vehicles, wireless power transfer.
There's a lot going on.
There is.
Okay.
So what gets you excited about these advancements?
Well, I think it's amazing how power electronics is going to be so important for a sustainable future.
Yeah, that's a great point.
With all these electric vehicles, smart grids, and renewable energy sources.
Right. The demand for efficient and reliable power conversion is only going to increase.
Exactly. And I want to be part of that.
Yeah, that's the kind of enthusiasm interviewers love to see.
So I could say something like, I'm really excited about the development of wide bandgap devices like silicon carbide and gallium nitride.
These materials allow for higher switching frequencies, lower losses, and higher operating temperatures, which means we can build more efficient and compact power converters.
That's a great answer. Or you could focus on a specific application.
Okay, look what?
Like electric vehicles,
All right.
I could say. The growing popularity of electric vehicles is pushing innovation of battery management systems, motor drives, and charging infrastructure.
Mm-hmm.
I'm really keen to contribute to these technologies and help create a sustainable transportation system.
So tying your skills to the trends.
Exactly. It shows your forward thinking.
I like it.
Remember, it's not just about knowing the facts.
Right.
It's about showing your genuine interest.
And why you care about these advancements.
Exactly.
Okay, what else do we have?
Let's talk about power quality.
Okay.
A common question is, what are harmonics?
Okay.
And how do they affect power electronic systems?
So harmonics, what are they?
Well, harmonics are like multiples of the fundamental frequency of the power system.
Okay.
They can distort the voltage and current waveforms.
And what does that do?
It can cause problems like reduced efficiency,
Ah, I see.
overheating,
Oh,
and even equipment failures.
so they're not good.
Not really. You could explain it like this. Harmonics are like unwanted noise in the electrical system.
Okay, like interference.
Exactly. They can be created by nonlinear loads like power converters and can cause issues like increased losses, transformers overheating, and problems with sensitive equipment.
So how do you deal with harmonics?
Be ready to talk about how to reduce them.
Okay, What are some ways?
You could mention using filters,
Okay.
multi-level converters,
Hmm.
or active harmonic cancellation techniques.
Wow, there are a few options.
There are, and by showing that you understand harmonics and how to fix them,
Right.
you demonstrate that you can design systems that meet power quality standards.
Makes sense.
And remember, RoleCatcher's AI can help you figure out which power quality issues are most important for the industry or company you're interested in.
Well, that's really helpful.
It is. It's like having a personalized guide.
All right, so we're in the home stretch now. Time to really polish those interview skills and get you feeling confident.
Yeah, let's jump into a question that often comes up towards the end of the interview.
Okay, what's that?
Do you have any questions for me?
Oh, right, that one.
Yeah, a lot of people see this as just a formality,
Mm-hmm.
but it's actually a great opportunity.
Oh, how so?
It's your chance to show that you're truly interested
How
and that you've been paying attention throughout the conversation.
so you're engaged.
Exactly. Plus, you can learn some valuable things that'll help you decide if this is the right job for you.
So it's a two-way street.
It is. So instead of asking generic questions,
Right.
try to connect back to something the interviewer talked about.
Okay, give me an example.
Sure, if they mention a specific project, you could ask, what are the biggest challenges you think this project will face in the next year?
Oh, I like that. So you're showing you are listening and that you're thinking ahead.
Exactly.
What about if they emphasize a particular skill set?
You could ask, what opportunities are there for me to learn and grow in this area?
Okay, so again, showing you're interested in developing your skills.
Exactly. It shows initiative.
Right.
Now, let's talk about the salary question.
Oh, yeah, that one.
It can be a bit awkward,
Yeah, it can.
but it's going to come up.
So how should we handle it?
Do your research beforehand.
Okay.
RoleCatcher has salary info,
Okay.
and websites like Glassdoor and Salary.com can give you an idea of what's typical for power electronics engineers.
Okay. Based on experience and location.
Exactly. Once you have a good sense of the range, you can confidently give them a range that shows your worth.
So, like, I could say, based on my research and experience, I'm looking for a salary between dollar amount and dollar amount.
Perfect.
Okay.
But I'm open to discussing this further based on the details of the role and the overall compensation package.
So you're showing you're flexible.
Yeah, and that you understand salary is just one part of the whole picture.
Right. What about benefits and things?
Exactly. Don't forget about benefits, bonuses, and growth opportunities.
Right. Those are important too.
They are. And RoleCatcher's career guides often give you some insights into company culture and benefits.
That's really helpful.
It can be. All right, let's touch on something else.
Okay.
How do you see the role of power electronics changing in the next 5 to 10 years?
Oh, that's a good one.
It is. It really tests if you can see the big picture.
And if you understand industry trends.
Exactly. Think about those emerging technologies we talked about.
Okay, like wide bandgap semiconductors, renewable energy, and the move towards electric everything.
Exactly. What excites you about these things?
Well, I think power electronics is going to be so important for building a sustainable future.
That's a great point to make.
With electric vehicles, smart grids, and all these renewable energy sources, we're going to need efficient and reliable power conversion more than ever.
Absolutely. And how do your skills fit into that?
I'm really excited to use my expertise in high-frequency power conversion and motor control to help make these things happen and contribute to a positive impact.
That's a fantastic answer. It shows passion and vision.
Okay, so before we finish up,
Yeah.
I just want to remind everyone about RoleCatcher's AI.
Yes, it's such a valuable tool.
It's like your secret weapon.
It is. It can analyze job descriptions
Okay.
and suggest keywords and talking points to help you tailor your answers for specific roles and companies.
That's amazing.
It is. It can even give you feedback on your responses.
Wow.
So it can identify areas where you can improve and help you get your message across more effectively.
It's like having a personal interview coach.
Exactly.
So we've covered a lot of ground.
We have, from those tricky technical questions to crafting answers that highlight your skills and passion.
I feel much more prepared now.
That's great to hear.
Yeah, remember, confidence is key.
Absolutely.
You have the knowledge, you've done the prep work, and you've got RoleCatcher to help you.
Exactly. You've got this.
Go into that interview and shine. The world of power electronics is full of amazing opportunities.
It really is. It's an exciting field.
It is. And we know you're going to do great things.
Best of luck.
Thanks for joining us for this deep dive. We'll see you next time.